So let's see how we can use sigma notation to speed up the process of calculating this area using our rectangles. Now, again, I said that you could simply just find the area being the length times width, find that for these 5 and add those together. That's perfectly fine. You can find that. But if we wanted to do this for, say, 10 or 20 or 30 or 100,000 rectangles, using the sigma notation is going to be helpful. But again, you don't have to use this if you want to just do this by hand. All right, so let's see what happens here. So I just drew the picture again, and I have these endpoints where if we're looking at just the right endpoints, we had this type of shape here. So remember, the total area is going to be the area of the first rectangle plus the area of the second rectangle plus all these until you get to the area of the fifth rectangle. All of these rectangles have an area formula of this width times this height. I'm going to add it to this width times this height, add it to this width times this height, and so on and so forth. So for each of these, I'm going to multiply this by 2/5. Right? I know that is the width that I have. Now my height is based off of this function, and I'm evaluating the function at 2/5. So I'm going to multiply this by f of 2/5. So we plugged in 2/5 into that, and we got some number. I'm going to leave it like this. I'm going to add on, for the second rectangle, I'm going to have 2/5, and then this height is determined by the function at 4/5. So this is going to be f of 4/5. And then I'm going to add on plus 2 times f of 6/5 plus 2/5 times f of 8/5 plus 2/5 times f of 2. Or you can think about that as being 10/5. So this is my sum. Now, we have to figure out how could I write this in sigma notation. Remember, sigma notation is going to have a sum. I is going to go from something to something else. So how far we go is going to be dependent on how many of these things should appear in our sum. So we have 5 of these. So we could end at 5 and start at 1. So if we started at 1, went up to 5, we can add 5 things together. All of these terms have a 2/5 present in them. All of them also have an f. So my total area I'm going to find is going to be 2/5 f of something. Now, what is this something? Well, we have to figure out how can I appear here, right? So this is going to be 2/5. This is going to be 4/5. This could be when I equals 1. This will be an I equals 2. This will be an I equals 3. If we think about what's changing is only the numerator. And so when I equals 1, I equals 2, I equals 3, we see the numerator could be 2 times I. So if I evaluate f at 2i divided by 5, this will be exactly the way that I could represent this sum using sigma notation. Now this maybe doesn't seem like it's going to be any easier, right? But we know what this function is. We know that this is negative x squared plus 5. So this becomes the sum from I equals 1 to 5 of 2/5. This is going to be negative of 2i divided by 5 quantity squared plus 5. So I plug this in. Now the f's go away, and I just have some expression in terms of just i's and numbers. So now we use our rules that we had of separating this sum and breaking it down. So this is going to be the first step, pull out the 2/5. So we have 2/5, the sum from I equals 1 to 5 of a negative 2i over 5 quantity squared plus 5. Pull out the constant. Now what I could do next is I could separate this into 2 of them. At the same time, I'm also just going to square this just because I can. So this is going to be 2/5. I have this first sum is going to be the sum from I equals 1 to 5 of a negative 4i squared over 25 plus the sum from I equals 1 to 5 of 5. Then here I have a constant in this I squared, so I can pull that out. So I'm going to have 2/5. I'm going to have -4/25 sum from I equals 1 to 5 of I squared plus the sum from I equals 1 to 5 of 5. Now, if you remember, we had formulas for the sum of I squared when I goes from 1 to n. And we also had the same thing for this constant. So if we remember what those are, we should remember that the sum from I equals 1 to n of a constant is going to be c times n. The sum from I equals 1 to n of I squared, that is going to be equal to I need my sheet actually. I don't really have these memorized right now. So we have I squared. Okay, n times n plus 1 times 2n plus 1 divided by 6. Okay, I will give you these on exams, by the way, on exams and quizzes. You do not have to memorize these. Maybe on a previous video I said to memorize them. Just become familiar with them, but if I don't have that memorized, you don't have to have that memorized. So here, so now if we know what these n values are, we could plug these in. So I, over here, have 2/5, -4/25. This sum, n is going to be equal to 5. So I have 5 times 6 times 11 divided by 6. And then over here, I have 5 is my constant, n is also this value, so I have 5 times 5. So now you just multiply, these are just a whole bunch of numbers, you add this, and I think this ends up being roughly 6.48. So we can do this, again, using sigma notation. The benefit of this is that if we wanted to say, what if it's not 5 rectangles? What if this is instead 10 rectangles? We could make some small adjustments and be able to evaluate that fairly easily. So this is what it looks like if we look at the right endpoints using sigma notation to get the sum as an approximate of the area.